So standard enthalpies of formation, you can find these in tables, and they're used to find delta H's for reactions and stuff. Really important thing to understand first off is that we set the enthalpies for elements in their natural state. So O2 gas is its normal state, so it's delta H formation, it's going to be 0. Hydrogen gas, H2 gas, is in its natural state, so it's going to be 0. Carbon comes in multiple forms. Graphite is what they chose, and so it's considered its natural state, so it would be 0. Where if we use carbon that's diamond, it'd be 1.9 kilojoules per mole. And that's for carbon diamond. And so we can go figure out the enthalpy of formation by going and making a balanced chemical equation in which we only make 1 mole of the substance we're interested in. And so you'll notice that, hey, we have a balanced chemical equation, but now we have half moles, maybe 3/4 of a mole, all sorts of numbers. The key is that we need 1 mole of the substance we're interested in, and on the left side is going to be all zeros. If we went and go and carried out the reaction that would happen, then we're going to figure out if it's endothermic or exothermic. Hey, it's negative, so when I take carbon, hydrogen, and oxygen and combine them to form C2H5OH, then we're going to have an exothermic reaction. It's going to take 279 kilojoules per mole. And so that's what enthalpy of formation is. And you just have to get used to writing these things from their natural state into 1 mole of the substance. And it's a little bit confusing because you actually have fractions in your balanced chemical equation. We're going to take carbon graphite plus some hydrogen gas, and they have to be in their natural state, plus some bromine. Bromine's a halogen, so it's going to come in 2. If you look on the periodic table, it's normally blue because it's a liquid at standard at 25 degrees Celsius and 1 atmosphere. I need 1 Br, so I need to come over here and put in a 1/2. I have 3 hydrogens, so I need to put in a 3/2. And then there's 1 carbon over here. And so they're really easy to balance. You just have to put in fractions where they need to be. Let's do the next one. Maybe you pause it and you do it yourself. So we're going to make CH3COC2H5 in the liquid state. I need 1 mole of that, so that's an implied 1. We got some carbons. We're going to start in graphite. The natural state. Got some hydrogens again, the gas state, and oxygen in the gas state. Looking on the product side, we have 1 oxygen, so I'm going to need to put in a 1/2 there. We got 3 plus 5 hydrogens, so that's an 8, so I need a 4 here. 1, 2, 3, 4. 4 carbons, so 4 there. Standard enthalpy of formation for sodium nitrate. Solid. Might have some sodium. It's normally a solid at room temperature. Nitrogen is a diatomic, so it's going to be 2, and it's a gas at room temperature. And oxygen again is O2 gas. So I start with, I need 3 oxygens, so I need 3/2 of the O2. That's supposed to be a 3. All elements are assigned a value for their enthalpy of formation equal to 0. Why? Because elements are the natural state, and we can't actually measure the enthalpy of an atom or an ion, so we have to set it at something. So we set it at the natural state at 0, and that's why they're always at 0. And then we can go and we can calculate by doing a reaction or series of reactions to figure out how much enthalpy it took or was released.